Good afternoon, class. Today what we're going to look at is what we call the tangent ratio of a right triangle. The reason we are looking at the tangent ratio is because this is a special ratio that we have memorized. Not necessarily memorized in our minds, but in calculators. It's because we are trying to find information in triangles so often, we decided to record it. The ratios that would be applied for certain angles of a right triangle, just to make our lives easier so we could go through certain ratios quicker. What we first have to look at is what we call a trigonometric ratio. The trigonometric ratio is a ratio of the lengths of two sides in a right triangle. Because the angles of a right triangle, in this case it ends up being angle A and angle C. Because they are always going to be across from certain sides, they're always going to be adjacent to certain sides, they will always have the same hypotenuse in ratio form for that angle, because any triangle that I have is going to be similar. So what we found out is that the side across from the angle, the side next to the angle, will always have the same ratio for a given angle. So what we did is we punched in our calculator all these angles. So for a 30-degree triangle, I might already know what the tangent ratio is. All right, for a 45-degree angle, I know that the tangent of 45 degrees is 1 because side over side it ends up being the same number. It comes out as 1. These are certain ratios that will always be true for given side lengths. And the trigonometric ratio that we are looking for here is just going to be the one for certain corresponding sides in a triangle, in a right triangle. So, the first one we're going to look at today is what we call the tangent ratio. Now, it is a trigonometric ratio of two lengths in a triangle. It ends up being the trigonometric ratio of the lengths of the legs of a right triangle. Specifically, it's the ratio of the opposite leg to the adjacent leg. So let me redraw the picture we have here. Now, for those of you that have gotten really good at a 3, 4, 5, 5, 12, 13, 7, 24, 25, and 8, 15, 17 triangles, you should almost notice right away that this is a 3, 4, 5 right triangle. Now here's the thing. This angle here, the ratio of the opposite leg and the adjacent leg. So I'm looking at this angle, the opposite leg is the one across, opposite. So if I look here, what if I said 15? So we're talking about the tangent of A here. That's 15 across. Now the adjacent leg ends up being 20. Well, if I wanted to know what angle A was, it doesn't matter exactly what number it is. Because in a 3, 4, 5 right triangle, it will always be the same ratio. This, when I reduce it, ends up being 3 to 4. And what we have in our calculator is when I plug in the number for this angle, which by the way, I believe this one ends up being 36.9 degrees. So if I punch in tangent of 36.9, I should get a number real close to 0.75 because that's the number that I get for the ratio of these two sides. So the tangent of this angle here is just going to be the ratio of these two. So if I would just quickly punch this in my calculator, which by the way, this is a new button on our calculator. If I look, there's this button here that says sin, although we call it sine. COS, cos, but it represents cosine. And TAN, no, that doesn't mean if you press this button you get a tan. No, it stands for tangent. That's this right here. So let me just real quickly punch in my calculator here. Tangent of 36.9. Now, if it's in the right mode, I should find that I get a number real close to 0.75. In fact, I get 0.75082. Why? Because I rounded this angle here. It's not 36.9, it's like 36.912. I don't know the exact degree. I rounded it. But it gave me 0.75, 3 to 4. Because that's what that ratio represents. Which, by the way, when I said if it's in the right mode, there's a different modes in your calculator. If you look in the bottom right here, it should say DEG, RAD, or GRD. Now, I'm not exactly sure where we use gradients, GRD, but you won't ever use them really in high school. You might use radians, RAD, but that's more of a calculus or advanced math type topic, or even physics. But for the most part, you want it in DEG, degrees. And that's just telling you what type of measurement you're using for an angle. Radians, degrees, and gradients are all different angle measurements used in other classes. Just make sure for your calculator here you're in degrees. So when you type in the tangent of 36.9, you get 0.75. If I would change my mode here real quickly to radians, and I re-entered the same thing in, I get negative 1.027. What? That's not the right ratio. It's supposed to be 3 to 4. 0.75. So I know I'm in the wrong mode. If you ever get the wrong answer for one of these and you wonder why, make sure your calculator's in the right mode. Some of the calculators you have bought are sometimes set default as radians, and you don't really run into any problems until you start dealing with tangent, sine, and cosine. But anyway, back to this. So this tangent ratio is just representing a ratio of side lengths. For A, it's opposite over adjacent. For B, it's the reverse. Opposite is now 20, adjacent is now 3. So if I look at the tangent of B, and I compare it to the tangent of A, I notice that they are reciprocals. Angle A and angle B are complementary. Tangent of complementary angles just end up being reciprocals. And I think that's what I say here. As seen below, the tangent ratios of complementary angles are reciprocals of each other. We can also use the same right triangle because the acute angles of right triangle are complementary. So I can use this and this angle here to represent complementary angles, and that's why the ratios are reversed, is because they're of the same triangle. But yeah, tangent is just a really fancy way for us to store the ratio, so that way I don't have to know exactly what the ratio is for each set of triangles. For each angle, I can make a specific triangle. However, we're not going to do that. We let the calculator do that. Tangent of 36.9 says, oh, hey, that's a ratio of 3 to 4. And right away gives us a decimal, 0.75. It's just going to be another way for us to be able to solve using proportions, but using only one triangle instead of 2 or 3. So let's look at a few examples. Set up the tangent of A and the tangent of B for this example. Another way this question is asked is to find the tangent of A and tangent of B. What they're just saying is set up the ratio that you get for it. Alright, so I know I didn't write this out fully anywhere else, but the tangent ratio, tangent of angle. I don't care what the angle is, but let's just put the angle here, is always going to be opposite over adjacent. So, opposite over adjacent. Let's just look at angle A first. Opposite leg, I really should have said opposite leg. So the opposite leg is all the way across. 36, that goes on top. The adjacent leg is the leg that touches, it's adjacent, it's right next door. Adjacent. So the adjacent leg would be 160, it's touching angle A. And it's a leg. So I do over 160. Now, because they just want us to find this here, we should really reduce this. 36 and 160 both have 2 in it, so let's do 18 over 80. They both have 2 in it again, let's do 9 over 40. And I think that's as far as we can go. Tangent of A equals 9 over 40. Tangent of B. So, let's erase this here. It's opposite over adjacent leg. So the opposite leg for B. So I'm looking at this angle. It might not be a bad idea to just highlight it in some way, shape, or form so I know where I'm starting from. Tangent of angle is equal to opposite leg. Opposite leg is across. So 160. Adjacent will be the leg touching. So 36. Oh, that's the flip around of tangent of A. No way. It works. Tangent of B, if I look at what tangent of A was, it ended up being 9/40. So I know when I reduce this, I should get 40th nines. But just to be sure, let's go through the work of this. So 160 divided by 2 is 80. 36 divided by 2 is 18. 18 divided by 2 is 40. 18 divided by 2 is 9. And I don't think I can reduce that any further. So tangent B is this. And there we go. Example 1 done. We've set up the tangent of A and the tangent of B. You will most likely see this question as find the tangent of A and the tangent of B. That just means set it up. Give me the ratio, 40 over 9. Sorry, 40 over 9, or 9 over 40. They don't want you to put this in a decimal. Unless they say round to the 4th decimal place, which in this case, then all you do is, hey, let's take 9 divided by 40, and I get 0.225. And I put 0.225 as my answer. Now if I would do the other one over there, 40 divided by 9, I would get 4.4444. And if they wanted just the 4th decimal place, I'd stop there, 4.444. All right? Example 2, it says find the values of the side lengths. The main reason why we're doing this is so we can find all the side lengths. So, there's a reason I wrote TOE at the top. You'll find out more later in the next section. Alright, so let's look at this one here. I don't know what the side lengths are, and that's what I'm being asked to find here. So let's put X and Y. Let's do the same thing over here, X and Y. Now let's separate the problem so I don't get confused. Alright, so look, I'm given one side length. Now, yeah, this ends up being a 30, 60, 90 right triangle. And while I know the shortcut because I just taught it to you and you should know it and you should be able to say, hey, this is 7 squared root of 3 and this over here is 14. But let's just pretend that, you know, I forgot about it. Test time, I'm going too fast. I didn't notice it was a 30, 60, 90. What do I do instead? Well, this is the angle I'm given. So this is the angle I'm going to refer to. So I'm going to mark it in some way that I know. That's where I'm starting. Now, I have to look for X or Y first. I notice I have 7. 7's my opposite leg. And the only one I know of right now is tangent. So right now, opposite and adjacent, I'm looking for X. So the tangent of 30 degrees. Yeah, that's right. If I have a number here, I'm plugging it there. Equals 7 over X. All right, I'm looking for X. Oh, I know. This is actually a proportion. What, Mr. H? It doesn't look like a proportion. I see one fraction and no fraction. Then make it a fraction. Cross multiply. 1 times 7 is 7. X times tangent of 30 is X times tangent of 30. I'm trying to solve for X. This here is a number. Plug tangent of 30 in your calculator if you don't believe me. It comes out as a number. So I'm going to divide both sides by tangent of 30. I get X equals 7 divided by tangent of 30. Calculator time, because I'm pretty sure we don't know this off the top of my head. So, 7 divide by tangent button 30. 3, 0. If you actually hit negative, it will throw off your answer. I have to delete negative. Close parentheses, so I have 7 divided by tangent of 30. Boom, I get a number. 12.124. Huh? Mr. H, we said that was 7 squared root of 3. Well, let's check. 7 times the square root of 3 is 12.124. Did it right. Yes! So I found one of the side lengths. Now to find y. Wait, whoa. I know 2 of the side lengths. This is 12.124. Pythagorean's theorem. 7 squared plus 12.124 squared equals y squared. Solve. I get 49 plus calculator time. 12.124 squared. I gotta make sure I punch this in correct. And I get 146.99 equals y squared. Add those two together, I get 195.99 equals y squared. And if I take the square root of both sides to see that I get a number real close to 14, 13.999. And that would even round up, because the next one would be a 7 rounded up. So this is, for all intents and purposes, 14. There we go. We use tangent of an angle to solve for it. Awesome. Well, let's do the same thing over here on the right. I look. I have only one side length. How am I going to solve this? I could use Pythagorean theorem, but for that I need two side lengths. So I have to use, it's going to be sine, cosine, or tangent. Right now we only know tangent, so that's what I'm going to use. Tangent of, I know only one angle, 36.9, so let's plug the number in, 36.9. Yes! Now, this is the angle I'm referring to. So, the angle across from it is y, and y goes on top. The side adjacent is 4, 4 goes on bottom. Solve for y. Well, again, I don't know what to do here necessarily, but it's a proportion. Cross multiply, 1 times y. Y. 4 times tangent of 36.9. And at this point, calculator time. Yep, you're going to be using your calculator a lot for this section. 4 times tangent of 36.9. Boom, I get a number, and I can look at it and I say, hey, 3.003 is y. Gosh, that looks strangely familiar. This is 3.003. Oh, I bet this was a 345. Yep, it's 345, just we rounded that angle, so that's why it's not perfect. All right, Pythagorean's theorem time. 3.003 squared plus 4 squared equals 5. Jumping ahead of myself. X squared. Well, this is 16. 3.003 squared. I get 9.018. So this is 25.018 equals x squared. Square root both sides, so 25.018 to the 0.5. And I get a number that's real close to 5, and I am not surprised. So, how do you find all the side lengths if you know one angle and one side length? Well, you pull out your tangent. Tangent allows you to find the other side or the adjacent side. I really should say opposite leg or adjacent leg, depending on what you're given. And then from there, Pythagorean theorem doesn't help. If you use Pythagorean theorem, you can find that third side. Lickety-split. This is not that bad. It might be a little bit challenging to set it up, but once you set it up, it's 1, 2, 3 done. All right, let's take another look. I think I have another example for you. What is the tangent of 45 and what is the tangent of 60? Does Mr. H mean, hey, look here, we got a calculator. Let's just plug it in. Tangent of 45. No. For this one, we know what a 45, 90-degree triangle looks like, and we know what a 30, 60, 90-degree triangle looks like. So, let's set up both parts. We know what it looks like, so draw both. All right, now you come up with the question. Mr. H, I'm trying to find what the tangent of 45 is, and I'm trying to find what the tangent of 60 degrees is. How am I going to do this? I mean, if I'm not allowed to use a calculator, what numbers? I don't know what the side lengths are. Well, that's the beauty of it. You don't need to. This is x. Well, then this would be x. And this would be x squared root 2. Awesome. What about over there? Well, I want the shortest side to be x. Because that means then this over here is 2x. This is x squared root 3. But Mr. H, I don't have numbers. What am I going to do? Don't worry. You're going to be fine. Now, tangent of 45. Choose an angle. You got 2 to choose from, but mark it. All right? Tangent is opposite over adjacent. So opposite is x. Adjacent is x. What's x over x? Well, what's 2 over 2? What's 3 over 3? What's 5 over 5? What's 1,000 over 1,000? That's right, it's 1. Tangent of 45 degrees is 1. No calculator needed. What about this over here? Tangent of 60 degrees. Well, let's look. Opposite. So opposite is across. X squared root 3 over x. Mr. H, I have an x on top and bottom. Well, that's fine. It cancels out to be 1. So what I have here is the square root of 3. The tangent of 60 degrees is the square root of 3. Look, that's an exact answer. You plug in tangent of 60 into your calculator, tangent of 60. You get this, 1.7320500808, so on and so forth. Square root of 3. Lot better answer. Just do this quickly. It'll please Mr. H if nothing else. That's what we do. We draw our triangle, we plug in what we know. We don't even need numbers to solve this. If you want to plug in numbers, great. Call this 2, call that 2 square root of 2. That's fine with me. Just plug it in and solve it. Example 4. Now let's use this in a real life situation. You're using something called a sextant. If you don't know what this is, it's a real simple device. Basically, what you take is a protractor and you attach a string to it. And what you do is you aim it right here. If it pulls straight downward, what it means is that 90 degrees here, that we're level. So 90 degree on a sextant here, the simple one I would have made at least, would be 0. That means no up or down. Now, if I would move it up as I'm aiming at something, let's say maybe a flagpole or something, now the washer or the string would fall straight down, and maybe it's at the 70 degree angle here, which means I have an angle of, well, what's 90 minus 70? Well, that's 20. So using a protractor, a washer, and a string, you can make a real easy sextant. And all it does is measure an angle of elevation, which, by the way, angle of elevation, it's the angle that we raise up. So here, if I would use this, I could then say, all right, I got an angle of 20 degrees. In this problem here, we were using the sextant, and it said you measure an angle of elevation, upward, to the top of a flagpole to be 40 degrees. All right, right now, I'd be drawing a picture. If you're not drawing a picture when they don't give you one in geometry, you've pretty much lost the battle of this problem. Because each problem is tough. You got to persevere through it. This problem, if you don't draw a picture, you're probably sunk already. So I'd be drawing a picture. I know that this is 40 degrees. You also, let's see, what am I trying to measure? A flagpole. So I must be somewhere near the base of the flagpole. And it goes up. So here's my flag. Not necessarily the best flagpole, but there's my flag. This angle goes to the top and the base. All right. You also know that you are standing 35 feet from the flagpole. So using a sextant, and you know how far away you are from the flagpole, could you tell me how tall the flagpole is? Whoa, wait, the flagpole's height is over here. How tall is that? That's just basically saying find x. I know the angle measurement. The flagpole I sure hope is a right angle. So, to find it, all I have to do is use tangent. Tangent of what? I have an angle. 40 degrees. Equals, well, the angle opposite my 40 degrees here. X goes on top. This adjacent leg is 35. Goes on bottom. I'm solving for x. Pretend it's a proportion. Cross, multiply. X equals 35 times the tangent of 40 degrees. Now, I haven't been strict on this before, but if it's inside the tangent originally, like 40 degrees here, that's the only number you plug into the tangent. If I plugged in tangent of 40 times 35 here, I'd be wrong. I'd get a wrong answer. Whenever I multiply a number times tangent, that number will always go in front of tangent because I don't want it accidentally to end up inside my tangent ratio. So when I punch my calculator here, I will always 35 tangent of 40 degrees. Now, some of your calculators are different. If you do not get 29.37 here, so x is 29.37 feet. That's the height of the flagpole. If you don't get that number, you did something wrong. Or you have a different calculator. If it's the second option, that's pretty easy to fix. Show Mr. H, he'll tell you how to use a calculator. If it's the first problem, well, that's a little bit harder to fix. What you're going to need to do is see me. I'll help you through the problem. Most likely it's you put the 35 in, or your calculator is actually reading 35, and when you hit the tangent, it's taking that. Either way, see me. Let me just check something real quick here. If you're getting the number 28.008, I know exactly what's going wrong. See me. That is all we have for today. So basically, whenever you are given one side length and an angle, we have now a way to find it. Even if it's not a 30, 60, 90, even if it's not a 45, 45, 90, even if it's not one of the special triangles I already know, I have a way to find it using tangent. So, if you're given one side and an angle and they ask you to find other side lengths, use tangent, use sine, use cosine. We'll get to that next section. All right, that's all I have for you today. Till next time.